So today we do not have anyone in online, but the offline strength is good. So it is better this way. Uh, okay. So yesterday we have completed till resource aggregate planning, right? So we have seen all the problems. Okay. So in resource aggregate planning, we have seen all the problems. Where we have all the strategies. We have seen all the pure strategies, and we have calculated different strategies and which will have the least cost, right? We have seen different problems in that. Today we will start with material resource planning, sorry, material requirement planning, MRP. Okay, so what is materials requirement planning? Material requirements planning is nothing but, you know we know that there's going to be a production happening, right? We know there will be a production happening, so we need raw materials for the production, right? So we need raw materials for the production, so we have to plan the raw materials in such a way that the production will get the exact quantity and exact time. So exact quantity at the exact time, right? So the raw material being available to the production batch at the exact quantity for the exact time is called material resource planning. Okay, so suppose we know that on the 10th of February, you know your production batch will start, and you will require 500 quantity of raw material. Okay, so you will have to plan. Now to plan it, you have to see what is the stock you have in your inventory. Okay, and what is your lead time, lead time. So once you place the order today, so how many days will you need for the order to reach your store, right, to your inventory? So suppose the lead time is 5 days and your stock is say 100. So at this point of time, you do not have sufficient quantity to meet your production batch, right? Even if you order the remaining 400 quantity today, today is what, 7th? So it will take 5 days, right? So it will reach only on the 12th. Okay, so to avoid such kind of a scenario, so to avoid such scenario, you will have to have a material requirement planning process. Okay, so this is MRP. And it should also not be in such a way that you need 500 and you are holding a stock of 1000. So this is again a waste, right? Because you are increasing your inventory cost. Correct. So efficiently managing your inventory of raw materials is material requirement planning. So this is a backward working. So if you know the end date and the time, so you have to work backwards to plan when you have to order and how much stock you have to maintain. Right. This is material requirements planning. Let us see what are the objectives of MRP. inventory reduction, reduction in manufacturing and delivery lead time, realistic delivery commitment, and increased efficiency. Okay. Yeah. So these are the objectives of MIP. So if you have an MIP planning process established, so you should have these objectives in mind while establishing the process. So as we have seen the last example, so you should not hold large inventory, rather you should time your inventory to production. Okay. See, it is not just that raw material should be available for production. You can ensure that by holding large inventory, but again that is not a very efficient process, right? So timing of your ordering is one of your objective. So this should be in your objective. Then reduction in manufacturing and delivery lead time. So if you have the process in place, there should not be any wait for raw material, right? Because you already know when and how much the raw material is needed, so this waiting will be reduced. So that will in fact reduce your manufacturing lead time. Okay, and similarly with the delivery. So you know that how much of your goods will be produced at what time, right? So your delivery channel or your distribution channel will also be available at the right time so that they can move your finished product to the market. Okay, so this also is comes under this process. Okay, and realistic delivery commitments. Okay, so because we have planned the entire process from raw material to production to delivery, so we have a realistic timeline. So we are not overselling or underselling to our customers, saying that we will deliver it to you, 10 days before the time. So that we will not do. We will not be doing that. Now, if you see today your Amazon and all, they will give you the exact delivery date because it is completely planned. So they will know when they will dispatch your item and how much time it will take for the transit and when you will get the delivery. And if you see it, they'll not miss the delivery date. It happens very rarely, but if you order something and they say it will arrive at this date to your address, it generally arrives at that date, right? So this is all resource planning, right? Requirements, material requirement, and then increased efficiency. So as we are planning everything on time and delivering it on time, ultimately efficiency is increasing, right? Any doubts? So functions of MIP. Okay, so as we have seen, as part of our objectives, so order planning and control. So when do you order the raw material? How much time does it take to reach your facility? right? So these are the main functions which your process should define, right? Similarly, priority. Now, if you have a product mix of say A, B, C, and D, okay, and you have priority, you have different priorities for this. So, if someone orders A, maybe you will have to deliver it in 10 days. B, maybe 5 days. C, 2 days. D, 6 days. Okay. So, based on that, you have to give priority to your product, right? So, which product needs delivery at what time? So that priority has to be given with the help of your planning process. Okay. And generally, what does planning do? Planning helps the capacity building on the long term. So this is a long term function where you will have to increase your capacity, and your capacity will increase in the long term, right? So this is material requirement planning. So you can go through the advantages and disadvantages. Okay, there is nothing much to explain over there, so you can give it a read yourself. Okay, and similarly, the second part, that is manufacturer resource planning also. So this is just an extension of MRP. So this you can say MRP2. Okay, this is MRP2, where it's just an extension. So this is manufacturing resource planning. So we have seen in the first part it is only related to material, right? But this thing is a more holistic approach. So it extends the same function of your material to the other departments, like your engineering department, your sales and marketing, and all of those other service departments as well. It is just an extension of your material to all the other processes, all the other business processes. Okay. Fine. So that is all about MRP 1 and 2. One is material and the other is manufacturing. So now we'll start with an important topic from exam perspective, and also this will repeat in many of your other papers also. Okay, it is economic batch quantity. So this is your most important topic of your unit 2, module 2. Okay. What is EBQ? Anyone heard of the term before? Sorry? Order quantity. Yeah, it is the same. EOQ and EBQ is the same. Correct, correct. So to explain it, so economic batch quantity, or okay, so there are many names for this. I will write down all of those names so that if they ask in a different way in the exam, you don't get confused. So remember what this is called. So EBQ, or economic order quantity, EOQ, right? Or economic lot size, or economic manufacturing quantity. All of these are the same. Okay, they are just used interchange, they just interchange the name and use it, but all of this is the same. Okay, so now what is economic order quantity or batch quantity? So what is it? So it is the quantity in which you manufacture your goods, okay, so that the cost per goods of that good is minimum. Okay, so say you are a manufacturing company, say, okay, and there's something called setup cost. So every time you start producing a batch, okay, so you have to set up. So you have to, get all your labor at that place, okay. You have to, set up your machinery, okay. Set up your machinery, probably calibrate your machinery, and you have to have your raw material logistics coming to your production cycle. So all of these will incur cost, right? So this is your setup, okay. So now suppose you say you have to manufacture 1,000 items. You have to manufacture 1,000 items, and you are not aware of economic order quantity or economic batch quantity, and you just start manufacturing, right? So you manufacture 10 today, and every time for you to start running this operation, or start running this machine, it will cost you 1,000 rupees, okay. And you manufacture 10 today, 15 tomorrow, 10 day after tomorrow. So every time you are breaking it in, for every day you are starting this process again, you are incurring 1,000 rupees, right? So this is not very economic. So your 1,000 rupees of your capital you are wasting, right? So, and then again you will have your storage cost. Okay, so you are manufacturing 10 today and you are selling, so your storage cost is 0. Okay, and tomorrow 15 you're manufacturing, you're doing 0. Okay, now you want to economize this process, so you want to manufacture all of your 1,000 at once, so that you will incur only 1,000 once, right? And but you can only sell 10, so you are having 900 in your inventory for today, right? And tomorrow you will sell 15 probably, so you will have 875, sorry, 990 in your inventory, and then again 975 in your inventory. Per day you are incurring inventory charges, right? So this balancing your number of batches of production and your inventory cost, at what level, probably where you can balance them well, so that your cost is minimum. So at that quantity is called your economic order quantity. You understood? Yeah. So if we look at what we have spoken in a graph, okay, so this is your cost per unit, and this is your quantity. So we have talked about setup cost, right? So every time the cost you incur when you run a batch, and we have talked about inventory cost. Okay. So as your quantity increases, your setup cost will reduce. Correct? Is this making sense? So suppose, as we saw the example previously, if you manufacture 10 units, okay, what will be your cost? So say this is 10, so this is 1,000. 1,000 is what we have manufactured, right? So 10 by 100, so this is probably 100. 100 per unit is your setup cost, right? So if you manufacture 1,000 units, then you say this is 1,000 units, so this will be 1. It will be 1 rupee per unit, right? So this is your setup cost. Okay. Now we will talk about the inventory cost. So the inventory cost increases with the quantity, right? The more you store, the more is your inventory cost. The more storage cost, because it is directly proportional to the quantity, right? So together, this point maybe, so if you combine both of these graphs, this is your setup cost, this is your inventory cost, If you combine both of these graphs, so you will get something like this. Okay. So see, this is increasing, this is decreasing. So you combine this, you'll get something like this. Okay. So this point is your EOQ. Okay. So at this point, your cost is the lowest. Cost per unit, not the total cost. Your cost per unit is the lowest at this point. Understood? Yeah. Okay. So before we proceed, there are a few important formulas. So these formula you have to remember, and this is very important. This will also repeat in your other papers also. So EOQ is equal to under root of 2AS by C. Okay. A is your annual demand or annual usage. S is your setup cost per unit. C is your carrying cost per unit. Okay. So generally this carrying cost will be given as a percentage of your production cost. Okay. So that will be your production cost per unit into the carrying cost in percentage. Okay. This is your EOQ. Fine. So what will be the units of EOQ? It will be units, right? Number of items, because see here at this point, so at this quantity, so EOQ will be in the quantity, your number of units. Okay. Fine. Let's solve a problem based on this concept. So we are looking at illustration 16, page number 75. Yeah. Okay. So he says the monthly requirement of raw material for a company is 3000 units. The carrying cost is estimated to be 20% of the purchase price per unit, in addition to rupees 2 per unit. Okay. So the purchase price of raw material is rupees 20 per unit. The ordering cost is 25 per order. You are required to find EOQ. Fine. So let us just write the data which he has given. So he has given you the monthly demand at 3000 units per month. This is per month. Okay. So this formula, if you look again, this is your annual demand, right? And he has given per month. Fine. Next, here he says the carrying cost is estimated to be 20% of the purchase price. So purchase price is also given, purchase cost is given as rupees 20. Okay. He says your carrying cost is 20% of purchase price. So it is 20% into 20. Okay. In addition to rupees 2 per unit. So plus 2. Okay. Yeah. And he says the ordering cost. Okay. So before we proceed, setup cost or ordering cost. Setup cost is also known as ordering cost. Okay. Setup cost is also known as ordering cost. This term is also used interchangeably. Okay. So ordering cost is rupees 25 per order. Yeah. He says you are required to find EOQ. So before proceeding with EOQ, we will write one more formula down. Okay. So we'll write one more formula for total cost. Yeah. So what is total cost? Total cost is nothing but your ordering cost plus your raw material cost, that is your purchase cost, plus your inventory cost or your carrying cost. Inventory cost or carrying cost. Okay. This is your total cost. Yeah. And your carrying cost also is nothing but your average inventory into carrying cost per unit. Okay. You can make a note of this. We'll see that in the problem anyway. This is EOQ. Shabby here. So this is your EOQ. This is your total cost, and this is your average, your carrying cost. So this part I've just expanded it here. Okay. Yeah. So let's go to the problem. You're done copying? Yeah. Yeah. So here, what is the first part? He says find EOQ. Yeah. So let's proceed with EOQ. So tell me, what is the formula of EOQ? Under 2AS by C. Correct. So now what is A? 3000 into 12. That is 36,000 units. Okay. Yeah. And S, or ordering cost, 25 per order, and carrying cost, we have seen what is the carrying cost. It is 20% of 20 plus 2, that is 20% of 2 is 4 rupees. Yeah, 6 rupees. This 6. Okay. So we can just place the values in this formula. 2 into 36,000 into 25 divided by 6. That comes out to yeah, 540.7. You can approximate it to 548 units. Any questions up to here? Nothing? Yeah. Okay. So that is the first part of the problem. So at 548 units, you will have the least cost. We can find the total cost. So let's find the total cost for this EOQ. Okay. So what was total cost? Ordering cost plus purchase cost plus inventory cost. Okay. So coming to ordering cost. So how will we calculate the ordering cost? If you look at the question, he says the ordering cost is rupees 25 per order. Okay. So we have to calculate how many times we have to order. Correct. So your annual demand is 36,000. So let us see number of orders we have to place in the year. 36,000 divided by, we are manufacturing 548 units per lot, right? 548. This is how much? 36,000 by 548. So we can round it to 66 orders. Okay. Now ordering cost will be your number of orders into cost per order. Correct? Yeah. So that is your 36,000 divided by 548 into 25. Okay. This is first. Purchase price we know. He says 20 rupees per unit, and we know how many units we have to buy. That is 36,000. Okay. This is simple. Now coming to inventory cost. So inventory cost, what we have seen the formula? We have seen inventory is average inventory into cost per unit. So average inventory, we generally assume it is 0. So it is 548 plus 0 divided by 2. Okay. Opening and closing. So this will be your batch quantity divided by 2 will be your average into 6 rupees. Correct? So how much this come to be? Hoping he got the right answer only. He says 723 268. 286. You can verify if you're getting the same answer. Yeah. So this is the total cost and your EOQ. That is part 1 of your problem. Okay. Okay. So let us see at the second part. He says, what is the total cost when the company gets a concession of 5% on the purchase price if it orders 3,000 units or more but less than 6,000 units per month? Okay. Okay. So he says the company will get a 5% discount if you place an order which is in the range of 3,000 to 6,000. Okay. So how shall we approach this problem? First, let us calculate the EOQ at the new price. Okay. Yeah. So the new price, so what is your purchase cost per material? He says on 20 rupees you get a 5% discount. How much is that? 1 rupee, right? 19 rupees you will get. Yeah. Okay. So this is 19. So what will be your carrying cost? Will be the same. So it is 20% of 19 plus 2. So instead of 20 it is just 19. Okay. So it is 3.8 to it is 5.8. So you have 1 rupee reduction in your raw material cost and 20 paisa reduction in your carrying cost. Now at this rate we will calculate the EOQ. So EOQ comes to 2 into 36,000 into 25. divided by 5.8. How many units does this come to? 557 units. Okay. Okay. So now let us calculate whether we are eligible for the 5% discount. Okay. So we have to order 557 units per batch. Okay. So he says to get this 5% discount, you will have to order 3000 units, above 3000 units and below 6000 units. Okay. Per month. So your order should be in the range of 3000 to 6000 per month. Okay. So let us calculate how many orders we will have to make per month. Okay. So this is 36,000 divided by 557. This is for the whole year, right? This is for the whole year. Now per month this will be year by 12, correct? So that will be 36,000 divided by 557 by 12, correct? So that is how many orders? 5.38. So this is 6 orders. Okay. So per order, how much are we going to order? So it is just 557 into 6, right? Because this is per order, we have already calculated. That is our batch size. So per order, we need this much. That comes to how much? I think this is above 3000, right? Because 5500 into 6 is above 3000. So this is greater than 3000. And it is less than 6000. Right. So if we order at this EOQ, we are satisfying this condition and we will be eligible for this discount. Okay. Okay. So now we have calculated this. Now can you quickly calculate and tell me the total cost for this batch size? Do it on your own and tell me what is the total cost. So total cost is ordering cost plus purchase cost plus carrying cost. So online, are you following?
Yes, sir.
This is the equation. This is your number of orders. This is order per cost per order. This is your price of raw materials. 6 lakhs 231. Okay. So this is, I think it is better than our first scenario, right? First we had 7,23,000, but here we are getting a 5% discount from our supplier. So this cost comes to 6,87,000. Okay. Yeah. So okay. Yeah. So now let's read the third part of the question. He says, so everyone is clear up to here, right? Yeah. Next part he says, what happens when the company gets a concession of 10% on the purchase price when it orders 6,000 or more? Okay. So similar to what we have seen here, he says we will get a discount of 10%. Okay. So he is going to increase 5% of discount if we order in the range of more than 6,000 per order. Okay. So first scenario 3,000 to 6,000 per order, and he gave us a discount of 5%. This scenario he's saying he'll give us a discount of 10% if we order more than 6,000 per order. So let's calculate the EOQ at the new price. Okay. So here you will have your purchase cost as 20 into 90%, that is 18. Your carrying cost is 2 plus 20% into 18. So that will be 82 5.6, is it? 5.6. So we had 1 rupee more reduction compared to the previous scenario, and 20 paise again reduction compared to the previous scenario. Okay, so let us calculate the EOQ at this range. Okay, so 2 into 36,000 into 25 divided by 5.6. So tell me how much that comes out to. 566.94. We'll round it to 567. Okay. Okay. So we have got this EOQ. Now let us see whether this will fall in the range of the 6,000 plus. Okay. So let us see how many orders per year. So number of orders is 36,000 divided by 567. How much is it? 5.29. So we not, as we cannot place 0.29, we will again go with 6. So now per order we will have to have 6 into 567, that is, so this is not much different from our previous problem. So it will be in the range of 3,000 something, right? 3,400 something. Okay. So this is definitely not in the range of greater than 6,000. Okay. So we cannot take at this discount at this EOQ. Correct? Yeah. Okay. So which of the 3 ways of the order should the company adopt? Okay. So if we cannot order it in this EOQ, if we order say 6,000 quantity, let us see what the total cost will come to. Okay. So total cost in this scenario would be, let me write the formula. So ordering cost plus purchase cost plus carrying cost. So this will be 36,000, and we have to order 6,000 quantity minimum, right? Into 25 plus this we will get at 18 into 36,000. Now the carrying cost. So see, if we have ordered at 567, the carrying cost would be less because we are ordering low quantity, but here we are ordering 6,000 quantity, right? So this would be your quantity we are ordering is at 6,000 divided by 2 into 5.6, was it? Yeah, or 8. 5.6. Right? Any question? How we got this equation? Okay. So how much will that come out to be? Calculate and let me know. 664950. Although this is not at our EOQ, this is the least of the three options. Correct? This one. So we are calculating what if we order 6,000 per order. We are calculating at a cost what if we order 6,000 per order. ठीक है, मतलब we are not calculating at EOQ, we are we are taking this 10% discount. ठीक है, supplier ने क्या बोला था, he said if you order more than 6,000 I'll give you a 10% discount. So we are calculating at his terms. Okay, so we are taking 6,000 per order and we are just calculating how much it is going to cost. And so that is why we have this also. So we have in inventory more 6,000. Okay. If we did not have this condition of saying order more than 6,000, so then your this thing will be 36,000 divided by 567 into 25 plus this same thing, plus you would have 567 by 2 into 5.6. Now if you calculate this will be very much less than this. That is why this is EOQ. Correct? But this is not EOQ, but still if we take this option, our price will be low than the first two options. Understood? So this at EOQ, this will be very much less than 6,64,000. But we are not calculating at EOQ, we are calculating at the 6,000 per order level. Okay? So now option 3 is better. Okay? Understood? Let's take a look at the next problem. Illustration 16, right? This is illustration 17. Page number 77. Okay. So he says MS Tubes Limited are the manufacturers of picture tubes of a TV. The following are the details of their operation during 2001. Okay. So average monthly market demand is 2000 tubes. Ordering cost is rupees 100 per order. Inventory cost is 20% per annum. Cost of tubes is rupees 500 per tube. He has given the normal usage, minimum usage, maximum usage, and lead time to supply. He is asking EOQ, that is the first problem, and if supplier is willing to supply quarterly 1500 units at a discount of 5%, is it worth accepting? Okay. Then maximum level of stock, minimum level of stock, and reorder level. Okay. Before we proceed with this problem, let us take few formulas. So maximum level of stock, this will be your maximum level of stock. This will be your reorder level plus reorder quantity minus minimum usage into minimum delivery time. Okay. And minimum level is reorder level minus normal usage into normal delivery time. Okay. And reorder level is equal to maximum usage into maximum delivery time. Okay. These are your formula. You can make a note of them. Now let us start solving this problem. So first part, he asked us to find EOQ, right? So EOQ is, we know the formula, so 2 AS by C. Now what is A? So he has given a normal usage for us, right? Normal usage is 100 tubes per week. To 52 weeks. That is 5200 tubes. This is your annual demand. Okay? Yeah. So rest of the, we can just substitute in this formula. 2 into 5200 into, what is your ordering cost? It is 100 per order divided by carrying cost is 20% of your, so this is 500 into 20%. much does this come out to be? So this is 100, right? 100 gets cancelled. So 5200 into 2 under root. So 102 approximately. Okay, here he has given 2 into 200 units into 100, so that is 5200 units. Okay, it's a typo in the book. Okay, let's quickly find the total cost here. Okay, so your demand is 5200 divided by 102 into 100 plus 5200 into 500 plus 102 by 2 into 100. Correct? How much does this come to? You give it to us. How much did you get? It's 5098 plus 5200 into 500, 26 lakhs plus 02 divided by 2, 5100. Comes to 26 lakhs 10,198. So if you make an observation here, generally your carrying cost and your ordering cost will be the same at EOQ. So if you take a look at that graph which we have seen, this is at this level, right? So at this level the cost is same. Okay, so because those two are equal, only we are getting the minimum EOQ. Okay, yeah. So now there's a proposal from our supplier. He says if we order 1500 units per order, you will get a discount of 5%. Okay, so at this terms let us calculate the total cost. So your annual demand is 5200 divided by 1500 into 100. So here there's no change, right? As in there's no change in your order cost. So your annual demand, and per order you're taking 1500 instead of EOQ and into 100, plus this will be 26 lakh, this will be 5200 into, So what is the purchase cost? It is going to be 500 into 95%, right? So that would be 475, and your carrying cost would be 475 into 20%. Okay, so that would be, this will be a 1500 divided by 2 into, so what is 475 into 20%? 95. So let us calculate the cost. This is 347 rupees plus 24 lakhs 70,000 plus 71,250. So we can see there is a significant increase in our inventory cost. From 5,100 it has increased to 71,000 because we have increased the quantity from 102 to 1500, right? So you have to carry a large inventory, but still whether this, so this is 20 25 lakhs 41,597, which is still less than our first scenario, right? So here it is 26 lakhs 10,000, here it is 25 lakh 41,000. So even if we buy at this quantity, the 5% discount will help us reduce the cost. Okay, understood? Yeah. Okay, let us look at the next problem. We have seen problem number 17, right? Yeah. Illustration 18. MS Kobo Bearings Limited is committed to supply 24,000 bearings per annum to MS Deluxe fans on a steady daily basis. It is estimated that it costs 10 paisa as inventory holding cost per bearing per month, and that the setup cost per run of the bearing is 324. Okay, so what is the optimum run size for bearing manufacture? So that is nothing but EOQ. Okay, what is the optimum run size? That is EOQ. So he has given us the total annual demand, that is 24,000. He has given us the setup cost or ordering cost, that is 324, and he has given you the cost of inventory. He says 10 paisa, that is 0.1 per month, so into 12 for the year. Okay, so this comes out to 3,600 units, correct? This is simple, direct substituting the values in the formula. Okay, okay, let's look at the second part of the question. What should be the interval between the consecutive optimum runs? Okay, so what should be the interval? So what does he mean? So he means how many days in how many days should you run one batch? Okay. So let us see how many batches we need to run in a year. Okay. So number of batches is equal to 24,000 divided by 3,600 per batch, right? So how much is that? Okay, 6.67 batches. So approximately 7 batches you have to run in a year, right? So if you have to run 7 batches in a year, so in how many days should you run each batch? So you have 365 days in a year and you have to run 7 batches. So how much is that? 50? Okay. $52.1. Let us say 52. Okay. So for every 52 days, you can run one batch, right? That is the question. Simple. So find out the minimum inventory holding cost. So minimum inventory holding cost is nothing but your carrying cost, correct? So that is 3600 divided by 2 into 10 paisa into 12 months. Two 160. That's it. So next question is a very simple question. Okay. He says a company planning to manufacture a household cooking range has to decide on the location of the plant. 3 locations are being considered, which are Patna, Ranchi and Dhanbad. The fixed cost of the 3 locations are estimated to be 30 lakhs, 50 lakhs and 25 lakhs per annum. And the variable costs are rupees 300, 200 and 350 per unit for each of the locations. Okay. The expected sales price of the cooking range is rupees 700 per unit. Now he says find out the range of annual production sales volume for each location. Okay. So he has given you the variable cost, the fixed cost and the revenue, and he says find the range of production sales volume for each location, and he has taken ranges of 5,000, 10,000, 15, 20 and 25. Okay, so you are just required to find the total cost. It's simple. You can do this at homework. Okay, there's nothing much in this problem. And the second part, he has given you 18,000. So for 18,000 units, he asks which location is best. So you can find out that also, which has the least cost at 18,000. Okay, it's a very simple problem. Yeah. So illustration 20, this is also a direct formula. It is EBQ. He says monthly demand for a component is 1000, setting up per batch is 120, cost of manufacture is 20, and rate of interest is 10%. So rate of interest is 10% is nothing but carrying cost is 10%. So if we see the formula which we have seen of EBQ, this is C as a percent, right? So instead of giving the carrying cost, you are just given 10% of the production cost. So that's it. Okay, so that is 2AS by C. Okay, 2 into 1000 into 12 into 120 is your setup cost by 20 into 10%. So he says it's 12,000. Yes. Okay. Yeah. Okay, so illustration 21. If you remember, we have solved this problem in our first class of OM. It is a time series question. Okay. So in time series, what is equal to 0? Let me see how many of you remember. So in time series, always sigma t equal to 0. The sum of the time is 0. You remember we derived a formula using this assumption. We have got two equations. Yeah. So this is the same problem. You solve this at home and you let me know what is the answer in the next class. Okay? Fine. Let us look at illustration number 22. Okay. Find the EOQ and the reorder point given. Okay. So annual demand is given. Average daily demand is nothing but annual demand by number of days. Ordering cost is given. Holding cost is given. Lead time and cost per unit is given. So quickly solve this problem and tell me the answer. What is EOQ? Can you solve and tell me? It's matching. 89.44, probably 90. Okay. Okay. And the reorder point or reorder level. So reorder level, we have seen the formula. Let us recap. Yeah. So this is maximum usage and into maximum delivery time. So has he given maximum usage and maximum delivery time here? No, right? He has given the lead time. So that is your delivery time, lead time, and he has given the annual demand, and he has given average daily demand. So when max usage is not available, you have to use the normal usage. So it means the usage is at a constant level. There is no maximum or minimum. Okay? Okay. So this is your normal demand into your lead time. Okay? So what is your annual demand? It is 1000 units, right? By 365 will be your normal usage per day. Correct? So how much is that? 2.73. So you are using 2.73 units per day. Okay. Now your lead time is 5 days. Okay. That would come to 13.69. Okay. Okay. So when you are calculating the reorder level, you have to be very careful when you are calculating. Now suppose the lead time is given in months. Okay. Then your normal usage should be in months. Correct? So you do not multiply days and months. Okay. You will make a mistake that way. You just take care that whatever usage per time is equal to the same time here. Okay. If it is in years, you have to do it in years. If it is in months, and days in days. Correct? Okay. So what does reorder level mean? So when your stock reaches this level, you have to place the order. Okay. So once you are at 14 units, you will have to place your order of 90 units, and in 5 days your 14 will become 0 and you will get your order. Correct? That is your reorder level. So once you place the order today, you will get your order before you exhaust this 14 days. Okay? So in some problems he will give a safety stock also. So that means this is playing it to the neck, right? So you are waiting for 14, you have 14, you order. What if something goes wrong? You don't receive. So for that purpose, you will have a safety stock. So in that case, your reorder level will be the same normal time into your lead time plus safety stock. Okay? So you will always have a reserve. Okay? And then you will have the same normal usage into lead time. Right? Okay. So let us close here before we do not want to overload. So we have a different type of problem where you will be given probability. We will see that in the next class. Okay? Any doubts? Neha?
No, sir.
Okay.
No, sir.
Okay. Please, do these problems at home also. Okay? That will help you remember better, because if you wait till your exams, you will not remember what you have heard in class. Okay? Yeah. Thank you.